Welcome to One Window class. Myself Soumyajit. I am going to discuss all this transformation in this lecture. Let me go to the first transformation in this lecture, that is a graph or function. Function f of x is getting transformed from f of x to f of minus x, right? Function f of x is changing to f of minus x. Then how the graph will change? We are only concerned about the changing graph if a function changes to f of x to f of minus x. Then you should rotate the graph 180 degree by y-axis, about y-axis. What does it mean? That means let me take one example for, let me say, e power x. This is very well known example, well known function, that is e power x. Graph is like this, e power x. Now according to the note, according to the statement, what it says, the graph you should rotate 180 degree by y-axis. That means you should rotate 180 degree by y-axis. If you just rotate 180 degree, then graph will look like this. Graph will go like this, right? This will be the graph of e power minus x. This will be the graph of e power minus x. Because let's say I'm explaining for this part why it is happening like this way. You take e power x for x tends to infinity, this will tends to infinity, and this will tends to, for x tends to minus infinity, this graph will go to, it will be tending to 0, because we know e power minus infinity is nothing but 0. That means, see, for the graph of e power x, this is going like this way. For x tends to infinity, the graph is taking longer value, taking greater value. For same way, if you take e power minus x, you see e power minus x, for x tends to 0, x tends to infinity, this will become e power minus infinity. That is why it is becoming 0. For this x tends to positive infinity, this will become this is for x tends to positive infinity. Now if you're taking x tends to minus infinity, so e power minus of minus infinity will become positive infinity, so this will become e power infinity. So this is tends to infinity. So this graph is like this. Now same way, if you consider the function of log, see the graph of log. We all know the log graph is like this way, right? So this is the graph of log. So if you rotate the graph, this will go like this. This is that much easy. You just need to know all this basic graph, so that you can do all the transformation that is necessary. This is also same fundamental is used like that I explained right now. Now let me show you in Desmos, either we have drawn right or wrong. Let me take e to the power x. See, e to the power x, the graph that I have drawn, e to the power x. Now if you change this e to the power minus x, how it looks like? Minus x. If you change it will rotate like this. Exactly 180 degree rotation you can observe here. 180 degree rotation. This green is e to the power x, and the blue one is e to the power minus x. If you increase the value of x, it will be near to 0. It will it will be near to 0. About f of x, for f of x, if you change the value of x, if you take the larger value of x, see, look at the output. Output is changing. Output is taking larger values, right? Same way, let me show you the graph of log x. Log x, this is log x graph, and this is log of minus x. See, this is exactly the mirror image. If you're considering this y as mirror, so you are just taking the mirror image of the function. Now let me proceed to the next transformation. Let me proceed to the next transformation, that is transformation 8. It says if a function f(x) is known, obviously you should know the function f of x. Now what do you have to, how you can plot the graph of minus fx? For this transformation, you should do the rotation about x-axis, 180-degree rotation about x-axis. Just rotate 180-degree. If you just rotate 180-degree x-axis, you will get the required graph. Let me show you the graph of f of x and f of minus x. Minus f of x. I will just take the same function e power x. I will take the same function e power x. We all know the graph of e power x. This is the graph of e power x. Now, according to our notes, it says you should turn x-axis by 180 degree. If you turn x-axis by 180 degree, how it will be look like? It will look like, see, right? That means x-axis is becoming mirror here. Just because this is e power x and this is minus e power x. Right? Now see here, you see e to the power x tends to infinity. For x tends to infinity, e to the power minus e to the power x will tends to 0 as x tends to minus infinity. Correct? Now what will be the case of minus e to the power x? It will tends to minus infinity for x tends to infinity. So this graph is below y-axis, below the origin. And this will be 10 to 0 minus e to the power x will be 10 to 0. It will tend to 0 when x tends to minus infinity. Right? So what we have seen, just observe here. You are changing this input. For this transformation, if you are changing the input, you should rotate y-axis. And here, you are keeping this input same, but you are changing the output. So graph is changing about x-axis. These are the key points that you have to remember to draw the basic functions graphs and their transformation. These are very much necessary to remember. Now I will show you some other example in Desmos. Let me take Desmos and draw some other graph. Now I have shown you log x. I have shown you as an example, I have shown you e to the power x. I am taking here minus log x. See, the graph rotates x-axis. And if you see, if you take ln of minus x, see this green is ln of minus x and blue is minus ln x and black is the original graph log x. This is function of log x. This is function of log of minus log x. This is the function. This is the graph of log of minus x. This is the thing. These are the things you have to remember. Now let me proceed to the next transformation, which is very important again. The graph transform f of x to mod f x. Mod of f of x. Now to draw this graph, these are the 2 points you have to remember. These are the 2 points you have to remember. First, what you have to do? You should draw the graph. First, you should draw the graph. Draw fx. And then next thing what you have to do? You should take the positive part and keep same as it is. That means leave the positive part of f of x as it is and take the mirror image of negative part. That means if the graph f of x is this way, this is the graph of f of x. What you have to do to draw this mod of f of x? What you have to do? You should keep the same part. You should keep the same part. Let me draw it properly. This is the graph of, I'm just taking one random example. Now what you have to do? You should delete this negative part and take the mirror image of this part and keep the positive part same. See, turn the portion of the graph lying below x-axis by 180 degree about x-axis. I will explain it. Just see it properly. Now what I will do, I will take one example. Y equal to x square minus 2x minus 3. What are the roots for this graph? If you consider here x square minus 3x plus x minus 3, that means x minus 3 and x plus 1. So that means roots are 1 and 3, right? Roots are 1 and 3. So we all know the graph of quadratic equation graph. We all know the graph of quadratic equation. This is the graph of, let's say this is, sorry, this is minus 1 comma 3. Now what you need to do to draw this y equal to mod of x square minus 2x minus 3, what you need to do? You need to draw first this x square minus 2x minus 3, and to draw this, what you just need to do? Keep this part same and delete this part and take the mirror image of this part about x-axis. That means this will be the required graph of mod of x square minus 2x minus 3. There are, let me explain you about the changes. Why this change, why this is changing? Because let's say f of x, mod of f of x, what is mod of f? Y equal to mod of f of x, that you have to draw the graph for. This is f of x when f of x is greater than 0, minus f of x when f of x is less than 0, right? Just see, take this value, this as a, and this as, let's say, a comma minus 5 minus b. Take this a comma minus b. That means for f of a equal to, you are getting minus b. But since you are putting this mod, that means you should get f of a will become b. That means for the change of mod, for the just if you're putting this mod, so this will, you will get the output as b. That means you will get here somewhere b. That is why this graph changes. Same scenario applies for sine also. Let me draw the sine x. This is the graph of sine x. Now, according to our key points, that you should keep the positive part same and just change the negative part. You should delete the negative part and take the mirror image of negative part. Take the mirror image of negative part. This will look like mod sine x. Because see here in sine x, for you will get this, if this is maximum, that means let me say this is pi by 2. So this will become 3 pi by 2 comma minus 1. Since you are putting mod, so sine of 3 pi by 2 is minus 1, that is fine. But what about sine of 3 pi by 2 mod? This will become 1. So the graph is changing. You will get here, this will become 3 pi by 2 comma 1. Right? So you should remember one key point here, that is, if you are applying mod in the output, see, mod in the output, you should take the rotation about x-axis, right? That I have told you previously. Okay, fine. We'll see some other example in Desmos. Take some other example in Desmos. Now I will take log x. This is the function of log x. Now if you are applying mod, see the changes. ln x. See, this is the mod function of log x. What happens? See the changes. See, the negative part of log x is not in mod. For log mod x, this will become the negative part is exactly changes to this. This is the function of log x and log of mod x. This is very important graph that you have to remember always. Mod log x. Take e power x. You see e power x also. This is e power x. You see e power x. This is the graph of e power x. So there is no negative part. Let me show you. Let me show you the mod of e power x. See, there will be no changing because there is no negative part. No negative part. No negative part. Output, there is no negative part of y. That means output f of no negative part of f of x. So there will be no change. There will be no change. Now, if you take cos x, this is the graph of cos x, right? That we all know. The graph of cos x is like this. Now, see the changes for mod of cos x. See how the graph look like. There is no negative part. There is no negative part. It all change. It goes to positive part. I think this is clear. Now we'll go to the next transformation. We'll go to the next transformation. That is, now we are changing output. We are changing input. We are changing input here. Now we are transforming f of mod x. What will happen? To draw this graph, first you have to draw the f of x graph. First draw f of x and then leave the graph lying right side of y-axis. Fine. And take the mirror image of f of x in the right of y-axis as the plane mirror, and the graph of f of x lying leftward of the y-axis is omitted. That means if you consider one graph, let me show you some example so that you will understand. I'm taking one random example, one random graph. This is the random graph I'm taking. Right? What you have to do? You should delete this part. You should delete this part. Left of y-axis, you should delete and take the mirror image of, this is the graph of f of x. Now, to draw this f of mod x, what will happen? Let me take this as 0 comma a, 0 comma minus a. So 0 comma minus a, you should draw take this part, keeps this part as same, and take the mirror image of this. Take the mirror image like this. Whatever the left part of y-axis, you should delete it and take the mirror image of right part of y-axis. That's all. Now I will show you one example. I will show you one function. Let me consider here e power x again. Let me take the example of e power x or log x, whatever it is. I am taking graph of e power x. We all know graph of e power x. So I am taking this example as e power x. Now you need to draw e power mod x. To draw this graph, what do you have to do? First thing you have to do, you have to take, like, neglect this part, left part of this, and take this mirror image of the right part, like mirror image of right part. This will become e power mod x graph. Why? Because see, this will become e power x when x greater than 0. When x less than 0, this will become minus e power x. Sorry, e power minus x. If you take, let's say I'm taking x as a, this you will get as b, right? I'm taking this as a comma b. That means e power a is you are getting b. What about if you are taking e power? What about if you are taking x equal to minus a here? Here if you are taking, that means minus of minus a will become e power a, which will also become b. So whatever the value you are getting here, you will get the value of here also. So the graph will change. You should delete the left part of y-axis of any graph. Take the mirror image of the right part. Same for log x also. So if you're taking log x, there is no left part. This is log x graph. There is no left part. So just take the mirror image of the right part. That's all. This is complete graph of log of mod x, basic. right? Okay, I think this is clear. Now I will go to Desmos to show you some other graph also. This is the cos x graph, right? This is the graph of cos x. You won't see the changes. See, cos of mod x. Put some bracket here so that Desmos will understand. See, there is no change because left part and right part almost they are symmetric. But in sin x, you will see the change. In sin x, you will see the change. This is the graph of sin x. And this is the graph of sine of mod x. See the changes. What happens? See, sin x, the green, the blue part is omitted. Blue part is omitted completely. For sine of mod x, see, there is no left part of, there is no left part, right? So these are the things that you have to remember. Without wasting time, let me proceed to the next one. That is, if a graph, now y equal to f of x is known, fine. If you are transforming mod y equal to f of x, if you are transforming mod y equal to f of x, then what will happen? Now, concentrate here properly. What you have to do? Remove the portion of the graph which lies below x-axis. That means if a graph lies below x-axis, you should remove the graph. This should be removed, fine. And now plot the remaining portion of the graph and also the mirror image of the x-axis. Fine. So the remaining graph, you should take the mirror image. If graph is going like this, so graph will go like this. So mirror image, you just take mirror image. This will be the for mod y equal to f of x. Now I will just take one example. Let me take some example. We all know y equal to x square minus, I'm taking one quadratic with known roots x minus 1 and x minus 2. First, what you have to, now this is the graph of, you have to draw the graph of y equal to this graph 1 and 2. These are the roots, and x equal to 0, then if x equal to 0, this will cut like this. This is the graph of y equal to x minus 1 into x minus 2. Now, to draw this mod y equal to x minus 1 into x minus 2, what do you have to do? You should remove the part. You should remove the part of negative part, that is below x-axis. You should remove this part and draw the mirror image. If it cuts at 0, 2, so it will cut 0, minus 2, right? And like this way, like this mirror image. This will be the graph of mod y equal to x minus 1 into x minus 2. You just remove this part. You should remove this part. That's all. Because same here, because output is changing. Right? For, let's say, y equal to sin x, we all know the graph of y equal to sin x. Y equal to sin x, we all know the graph of y equal to sin x. Now what you have to do, you just need to delete. You just need to delete which parts? Delete the negative part. Delete the negative part. You should delete this part. You should delete completely these parts. Now, if you plot the graph like positive part, you just keep the positive part same. Positive part same. Right? Here, this is the positive part according to this graph. Now what happens? You just take the mirror image. You just take the mirror image. That's all. The graph of mod of sin x. Sorry, mod y equal to sin x. Correct? You can plot taking any inputs. You will get like this. Take any input x as pi by 2. You see the main graph. You see the main graph. Sin x equal to will become, for y equal to x equal to pi by 2, sin x you will get 1. So this pi by 2 you are getting 1. Now mod y is 1. Why? When mod y equal to 1, for y equal to plus minus 1, so the graph you will get here minus 1 also, right? So these are the things that you have to remember. Now we'll see in some Desmos also some graph. Let's say let me consider some graph in Desmos so that you can see the changes also here. You take any graph you want, but I am taking here, let's say let me take some graph as cos x. You take cos x. Y equal to cos x. This is the graph of y equal to cos x. Now you see mod y. You are taking mod y equal to cos x. See the changes. You are just taking the mirror image of the positive part. That's all. That's all. The graph. You see for the same part for log x also. Y equal to, you say log x ln x. You see mod y equal to ln x. See the green part, this negative part is already removed. For this negative part is removed. Now for this, see this is the mod y equal to log x. Correct? These are the transformation that you have to remember. There are some more transformation as well that we'll discuss in the next video. So that's all. Today's all this lecture. If you have any doubt, you can ask me in comment so that I can answer you properly. Thank you.